then, so we'll go through this very slowly. Now, the USB cable to the power supply and breakout board inside here is connected to the computer. The next thing we need to ensure is that the supplied USB drive is in the computer also. Turn on the power into our unit and make sure that the emergency stop button is out. Also turn the speed controller into its maximum position. You should have 3 lights up here. Okay, there are a few reflections off the screen in the workshop here, but we'll do our best. What I'm going to do now is come down to here and open up the USB drive. And the first thing we need to do is to put the driver into the computer. Now I must stress, the power supply unit for the CNC router and breakout board needs to be turned on and connected via the USB cable into the computer. So we're going to open this driver now. I'm going to double click on this driver. I'm going to say yes. And we're going to say install. Driver installed successfully. Okay. Well, now we can get out of that. And we're going to press up. Okay, so I've switched to screen capture because I was getting a lot of reflection, and I did check the camera, and no. So you know, you're going to get a better visual just by me doing a screen capture, and I'll put a view of the machine you know, somewhere on the screen as well, so you can see what it's doing. So just now I found I couldn't open the UGS file from the USB drive which was provided with this machine. Don't know why. As you saw, the file for the driver went through okay. So we'll pick it back up now, and I've downloaded it direct from UGS, and it's in my documents. This is a fresh computer, by the way. I did a video on how to replace the hard drive on this particular computer, and I downloaded Windows from Microsoft, but it's saying about activation here because it tried to upgrade to Windows 11 and it won't go on this computer. So long story short, here we are, UGS, and it's already unzipped, and we open the files, and what you're looking for is the bin file. So I'll open that, and we're looking for 64-bit. Now this is actually your thumbnail then for opening the program. So we'll open the program. Okay, so when you open UGS, it's going to look something like this. It should look something like this. So we're going to get rid of this for the moment, and I'm going to, here in this window, I'm going to bring up the camera view of the CNC router. So that will enable you to see exactly what the router is doing. You can see I've put a piece of material there, and I've also connected up the Z height puck or gauge, and I've put a tool in the spindle. Right, so now earlier on we checked to see which COM port the driver went into, and also the connection to the power supply and breakout board, the controller for the CNC router. So we know it's COM3. We'll just check. There's nothing else there. It's the serial COM port 3. We're running GRBL. Now at this point it's all grayed out. So what you do to connect the computer or this program to the router is you come here and press that, and things will begin to happen. Okay, so there. Now I'm going to show you just a few items to change to get your machine working somewhere near as it should. So I'm actually working in millimeters. So what we're going to do, this is the step size. In other words, how many millimeters the jog is going to go. How it's going to move when you press the jog keys. At the moment, each depression of each key here will move it just 1 millimeter. Well, that's a little bit sort of. We can raise that up a little bit for the purposes at the moment. So I'm going to say for this 25 millimeters per press of this. Of course, you can alter this to whatever you want. So you can bring this number down, as fine as you really want to. So you can be very accurate, or move it, sort of a very small amount if you wish. So I tend to go sort of 25, and we're going to go 10 millimeters. No, actually, we're going to go 5 millimeters for the Z. Now, 100 millimeters per minute. That's very slow. So what we're going to do is, for jog speed, or rather for feed rate, we're going to go look, anywhere between 1000 and 1500 is fine. So we'll go 1500 millimeters per minute. That's okay. We can take it up to possibly 2000 and probably a little bit more. I think they recommend 2000, but I'm sure it will handle a bit more than that. So the next thing we need to do now, you keep an eye here on the screen, and let's try moving the X 50 millimeter in X plus, which is to the right. Oh, look at that. Isn't that beautiful? 25 mil. Let's go another 25 millimeters. That looks about the middle of that material, which is fine. Let's make sure let's make sure that we go in all directions. Go back, and we're going to come forward 25 and back 25. That all looks good. And if you see here, you can learn a lot from this window. Actually, it's telling us that jog, right? G2, G21, G91, X25 feed rate. So we're going to jog the machine in the X direction, 25 millimeters in length, at a feed rate of 150 millimeters per minute. This is G code, and that is the instruction the machine just did. Okay, let's go now 5 mm down, or in the Z. In this case, the minus, and indeed it does go. There we go. That's all looking good. Now, as we are here, I'll show you how to get some of these other windows up, because we're going to need the window for the Z, you know, for the puck to do the Z height. So we're going to go in Window, and we're going to come down here to Plugins, and we're going to come down here to Probe Module. Press that, and there's the probe module. So you can shuttle back and forth, you know, if you want to see the G code, there it is, or indeed if you want to put G code in. But we need the probe module. This is the settings for the probe module. We're just using Z. So there's something we have to do here. Now I'm just going to get my vernier gauge. Hopefully you'll be able to hear what I'm saying. But so I'm coming across here now, and I'm just checking to see what this is. Okay, that's 19.34. Okay, so we're going to come in here now and write 19.34. Probe distance. Now this is the distance that you need to be within from the top of the probe. It will, and this figure actually also needs to be a minus figure, because when you move the Z down, that is the minus direction. If this was a plus, obviously it would go, you know, looking for the probe in the up direction. That's what you don't want. So let's set the puck size accurately, and we are telling that we want the probe, or the end of the tool, to go looking for the puck then in the minus direction, which is the down. So I'm just going to put the puck underneath, and so we're going to put the puck underneath, and the crocodile clip goes on the tool. Hopefully that's going to be all right there, like that. I'm going to have to drop it down slightly, because that looks a little bit more than 10 millimeters to me. So we got this set at 5, and we're going to say come down 5 millimeters. In actual fact, that still looks more than 10 millimeters to me. So I'm going to alter this now to 1. And let's come down 1 millimeter at a time. Okay, that'll do. That's fine. So now we're going to go into settings. Now this is the normal settings. I've actually got to take, we're not going to worry about this at the moment, because all we're doing is, you know, a Z probe in action. Retraction is 1 millimeter. So this means when the probe goes down and finds the puck, it's going to retract off the puck 1 millimeter and retry again. So it's going to initially come down at a feed rate of 100 millimeters per minute, which is, you know, nice and slow, but it's safe. Then it's going to retract up 1 millimeter, and it's going to come down slowly at 10 millimeters per minute. So that, you know, the slower that you can do this, the more accurate you know, you're going to be. Okay, so now we've got our measurements in there, and we, you know, have got all our settings. We've checked our settings to see if they're correct. We can now go to initiate the probe and see if it works. So here we go. Perfect. In case you missed that, I'll do it again. There you go. And indeed the Z has it's actually zeroed. Now we put the measurement in of 19.34, and it's retracted up, what's that, 5 millimeters? 19.32, yeah, something like that. So the probe knows exactly how far down the material is, and if we measured that, it would be 22.371 millimeters off the top of the material, nearly an inch. So we know that's right. I mean, I can see that, you can see that on by the camera, that yeah, it's pretty well an inch. So I've got no problem with that. So the next thing we're going to want to do is come up to Machine and then come to Actions, and now we want to tell UGS to remember or zero the X, and come back up to Machine, Actions, and come down to the Y. So now the three axes, the X, Y, and Z, are locked into UGS. So now I'm going to ask UGS to register the machine home. And we do that by coming up here to this little house and press that. And it's as simple as that. Okay, so I think that's enough for this video today, because, you know, we could go on and on and on. The next video we will actually, you know, run a job. We'll cut a job. Something sort of fairly decent, not just scribe a line or just cut a little pocket, and I will do a real job with it. And in the future I will go into more depth with UGS and show you, sort of all the features within UGS which you may like to know about. So thank you for joining me for the video today, and I hope you've enjoyed it. Please like and subscribe, and if you really like what I'm doing, you may consider becoming a patron to the channel, because I purchase all my machinery myself, and to enable me to put out good content, sometimes we need a little help, because the revenue from YouTube is pretty well no more. So thank you for watching my video, and I hope you pop in and have a look at some more. So it's bye for now.